All right, here's your integrated 3. It's your homework packet. This is number 12, and it wants me to graph. It wants me to graph and completely describe each of the following functions, and be sure to label each graph carefully so that all key points are identified. So this one, I can look at it and I can identify it as a exponential function, and you learned about exponential functions first when you were in integrated 1, and I think you still worked with them in integrated 2. You might not remember they're y equals a times b to the x. So I can tell a lot of things just by looking at the form of it. This number is bigger than 1, so I think it's going to end up being increasing. I think it's going to start at 2. Like, I'll bet you that there's going to be a point right here. But when in doubt, if you don't remember anything about what you learned in your past classes, you can just go ahead and plot some points. So I'm just going to plot some points. I think I know that it's going to go like this somehow, but I always pick -1, 0, and 1. So pick -1, and then I have to do a little bit of, maybe you can do this in your mind, or maybe you want to use a little scratch paper. When I plug in -1, I have 2 times 3/2 to the -1, but that's the same as 2 over 1 times. When something's to the -1, you flip it upside down, you make the reciprocal, so this would be, so that's 4/3. So I had to use some scratch paper to do that. Now when I plug in 0, 2 to the, well, anything to the 0 power is equal to 1. So 2 times 1, that's just 2. And then if this is to the, if I raise x, if x is just the number 1, then I'd have 2 times anything to the first power is itself. And the 2's cancel out and I get 3. Now I'm going to go ahead and plot those and see how everything looks. And then I'm going to maybe choose some points to the left or the right, or, you know, some more negative or positive. But I always just like to get a little look at it. So at -1, I've got 4/3. So 4/3 is more than 1, right? It's like 1 1/3. So I think it could be, I could say it's about there. And then 0 and 2, when x is 0, y is 2. So right there we got a y-intercept. And when x is 1, 2, 3. So I think it's probably going to end up going up like that. Let's get some points to the left and the right. So let's try -2. So I'm going to use scratch paper on this. Just plugging it in. So this is going to get flipped upside down and squared. And this is 2 over 1. So this is 2 over 1 times 2 squared is 4 and 3 squared is 9. So this is pretty tedious, isn't it? 2 times 4 is 8. But you can do it, 8/9. Hopefully we won't have to do very many of these. So I got -2 gives me 8/9. I really think I can predict that this is just going to curve down here because of what I know about exponentials. But I mean, if you wanted to try one more, let's try one more. Let's do -3. So, and you can always get out a graph. I guess you can get out a graphing calculator and look at this too. So let's just do one more. I'm just to be sure. If I plug in -3, that's 2 over 1. I'm going to wish I didn't plug in -3, huh? So that's 2 over 1. 2 cubed is 8. 3 cubed is 3 times 3 is 9 times 3 is 27. Well, I kind of wish I didn't do that. 2 times 8 is 16. 16/27. Well, I don't think I'm going to take it any further. 16/27 is a smaller fraction than 8/9. I know that. So I'm going to just go ahead and call it quits. I know that there's some end behavior. I know that it's just going to get smaller and smaller. And that should make sense to you, because what are we doing when we're putting these big numbers in here? If I stick a -4 or a -5, it's taking this, turning it upside down, like making the reciprocal of it, and then it's raising it to a big power. So, I mean, you can pause the video and just think about that for a little bit, why I know that it's just going to keep getting smaller and smaller. And then this one's going to go, I expect it to go up and up and up, just like any old exponential function that I've seen before. I'll go ahead and, I tried 0 and 1, I'll try maybe 2. So, use a little scratch paper again. So it's 2 over 1, and then 3 squared is 9, and 2 squared is 4, so that's 18/4. So that's pretty big, right? 4/4, 4 times 4 is 16. So that's going to be 4.5, I think. You can go ahead and do that math on a calculator or something, but I think that's going to be about 4.5. Or you can use a yeah. Okay, so 1, 2, 1, 2, and then 1, 2, 3, 4, and then I'm just going to fake the rest of it. I already know it's going to shoot up. It's an exponential function. So now when I'm describing it, I have to do all the things they told me. They told me to completely describe each of the following functions. So my graph is labeled pretty well. I've got the x and y axis. This right here is an asymptote, because the number is going to get closer and closer to 0 and never reach it. That's what an asymptote is. I don't know. I don't think it looks like there's going to be an asymptote here, but I think it's going to just ever so slightly keep moving off to the right as it moves up. So I'd say there's just a horizontal asymptote at y equals 0. The x-axis, which is y equals 0. I'm going to say it's an increasing function because it increases from left to right. The y values increase. There's a lot of things that they gave us kind of a way to describe things. There's a lot of things you can say about a function when you fully describe it. The shape, I don't know. I want to just say, you can say it's curved, but I want to say it's exponential. It's shaped like an exponential. What else would I like to say? There's a y-intercept. Y-intercept at y equals 2. So there's that. What else do we have? Is it a function? Yes. Did I say it was a function? Yeah, I said it was a function right here. It's continuous. I think I made a video and I forgot to say it was continuous. It is continuous. Well, some of them are, some of them aren't. This one is. I don't think it has any endpoints. Let's do the domain and range. So domain is all real numbers. Any number, because that's the x values. But the range is y is greater than 0. And that's because there's no y values below 0. And let's see if that is matching with what they have. Yeah, they said it's exponential, it's increasing, horizontal asymptote, y-intercept domain. Okay, so that's it.